Okay, on problem 23, we see that we're going to take the log base 4 of x is equal to minus 3 halves. This means that 4 is being raised to the minus 3 halves, and that will equal x. So we write it in exponential form first, like this, and then you just say x is equal to, and put this in radical form. 4 to the minus 3 halves gives you the square root, that's the denominator. 2 is the index, so we're not going to put a 2 there. 4 to the minus 3. 4 to the minus 3 is 1 over 4 cubed. So this is all inside the radical sign. And then you come down here, and 4 cubed really factors into 4 squared times 2 squared. Well, once you have 2 and your index is 2, you bring out 1. So you end up with x is equal to 1 over 4 times 2, which is 1/8. And that's how that one's done. Now, you don't have to split this up into so many steps. I just did this so you could see how I got from here to here. Now on page 470, number 25 and 26, I'm going to do log based x of 27. Now here's where you're going to try to find the base. So x is being raised then to the 3 halves and equal to 27. So you raise x to the 3 halves, and then how you undo a variable raised to a power, you know that you just raise it to the reciprocal power. But when you do that to the left side, you have to do that to the right side. And so when we do that over here, we just end up with x to the first, because the 3's cancel and the 2's cancel. So x to the first power, or just x, is equal to the cubed root now, because the 3's in the denominator, so that's your index, times the square root of, or the cubed root of 27 squared. That's what I meant to say. So then you get this at 27 squared is really, let's factor this. So we have 3 to the 6th, and I need to take out 3 factors alike to bring 1 out in this case. So since there's 6 3's in there, I can bring a 3 squared out, which then makes the problem equal to 9. Problem number 26. Log base x of 64 equals 6 says x is being raised to the 6th power to equal 64. What number raised to the 6th is 64? So you set the equation up in exponential form like this. Then, since this is raised to the 6th power, I'm just going to raise both sides to the 1/6 power, or take the 6th root of both sides, is the same way of saying that. So you get x over here is equal to the 6th root of 64, and if you punch that into your calculator, or if you factor it out, you'd get x equals 2. Okay. Number 31 is a show that. Now a show that is a proof. Believe it or not, it's an algebraic proof, and whenever you see the word show that, you'll know it means prove. And it's really not that difficult to do when you look at this. I know you'll say it's terrible, but it's not. Log base 2 of 8 plus log base 2 of 4 is equal to log base 2 of 32. You write this statement as exactly as it appears. Now you'll notice that I put part of it, the left side is in green and the right side is in this reddish orange color. Now, the reason I did that is to show you, and I kept it on the left side, we're only working with one side at a time. When they say show that something is equal to something else, the object here is to take one side of the equation and simplify it until you come up with the right side. In this particular case, I simplified both sides, but I didn't do it at the same time. So I worked the left side down. So I took this left side right over here, and I said, well, log base 2 of 8 is 2 raised to what power is equal to 8? Well, 2 cubed is equal to 8, so the log base 2 of 8 is equal to 3. And now looking at this one, 2 squared is equal to 4. 2 raised to what power is equal to 4 is what that says. So the log base 2 of 4 is equal to 2. Now this gives 3 plus 2. Well, that's equal to 5 for the left side of the equation. Okay, so 5 now we put in for the left side is equal to the log base 2 of 32. Now look at log base 2 of 32 on the right side and simplify the right side. We get 2 to some power is equal to 32, and since 2 to the 5th is equal to 32, Then the log base 2 of 32 is equal to 5, giving 5 on the left side is equal to 5 on the right side. And that one's done and proved. Part B of that same problem was to show that the log base 9 of 3 plus the log base 9 of 27 is equal to the log base 9 of 81. Done the same way, so I took the green side on the left, so I simplified this. 9 raised to what power is equal to 3? Well, we know that the square root of 9, which is 9 to the 1/2, is equal to 3, so that the log base 9 of 3 is equal to 1/2. Now, once you have this, you set up an equation for the other one. This one right here is 9 to what power is equal to 27. Just this side right here. It's still on the left side of the equation, so we just set up this equation because it's not so obvious. So write each side as the same base raised to a power. 9 is really 3 squared, so I'm going to substitute in 3 squared for 9. So I have 3 squared raised to the x is equal to 27 is 3 cubed. So now I have the same base. And now I just have to set my exponents equal, like we've done. So 2x, 2 times x are the exponents on the left side, and 3 is the exponent on the right side. So 2x must be equal to 3. Therefore, x is equal to 3/2. So now we go back to the original problem we had for the log base 9 of 3 up here. We had 3 plus 3/2. Okay, so the left side of the equation becomes 2 because we have 3/2. Oh, I forgot, that wasn't 3 up here. It was 9 1/2. 9 to what power is equal to 3, so it was 1/2. So we're actually adding 1/2 and 3/2, which gives you 4/2, which is 2. Okay, now the right side of the equation, we're going to have to keep going back up here. Right side was log base 9 of 81. 9 raised to what power is equal to 81? Well, you know that 9 squared is equal to 81, so I know that this right side is going to be 2. And that's what we find out. We had our left side was equal to 2, and the right side is equal to 2. And since both sides simplified to 2, they're equal, and you've proved that. So what's the conjecture here? That's the thing. From the two examples in this part, you're going to see that 32 was the sum of the logs of its factors of 8 and 4. Now, if you look at those, you'll realize this, what I'm talking about up here. Okay, all the way back here to part A. 8 and 4 and 32. When you think about this, 8 times 4 equals 32, doesn't it? So I added the log of 8 and the log base 2 of 4 to get the log base 2 of 32. So what this is telling me is that if I had two numbers being multiplied together to get a third number, it might be simpler to just add the logarithms of those two numbers to get the sum and then take the anti-log. And you're going to learn these properties of logarithms. So 81 turned out to be the sum of the logs of its factors of 3 and 7. So on this problem right here, 3 times 27 equals 81. But when you add the two logs, you get the log of 81. So, and they were different bases to just show you that. So you could conclude that the product of two numbers is equal to the sum of their logs, which is true. I'll do problems 35 and 36 on the next video.